Okay. Well, what I'll do is actually there's some cool stuff in here. There's a book and a T-shirt and some other BS. But the neat thing is we've got a certificate for one of our training classes. So it's like a 2 or 3 day class. Any of our classes in 07. So if you're interested in that, I'm going to pass around a couple envelopes. Just throw your business card or your name and an email address on there, and I'll draw someone at the end. But that's, I think, a couple $1,000 that might be worth. So if you're interested. If not, just go ahead and pass it around. That's cool. But the other thing I mentioned is I'm also a member of the, oops, I hit 2 slides. Page up. Sorry, here I got to get, there we go. Yeah, I mentioned I'm a member of the local OWASP chapter for the DC area, and that's why I got my shirt here promoting them as well. But I think some of you guys might be interested in application security, and if you're interested, you should come. I mean, we have monthly meetings. Like I said, I'm part of the DC chapter that either in the DC proper or in Maryland, but there's also another chapter that meets in Northern Virginia. We meet once a month, typically, sometimes a little less often, and we meet typically on a weekday evening, so it's not taking up part of your weekend or anything. So check it out if you're interested. But I wanted to put that at the beginning just to make sure I got to it. I will kind of caveat my presentation a little bit. Oh yeah, there's the leader of our fine organization is there. One of the leaders, yeah, half of our leadership team. But I will also caveat my presentation a little bit with I have a lot of slides. I think I have up to 107. So I know I'm not. There's a lot of screenshots though, so I'm going to go through some of those quickly, and I may skip over a couple things as we get to them. I just got to the point where I just kept wanting to add new stuff. So if you want to take a look at them later, though, we can go in them into more detail. And like I said, I may skip over some things as we get into it. I want this to be kind of an interactive presentation. So if you have questions or comments, feel free to throw a Shmoo ball or to throw your hand up. My company has also seen fit to arm me with some stress balls that I can throw back. So just be forewarned. So, okay. Oops, I didn't talk about that slide, did I? So the problem that we ran into, and this actually kind of started at an OWASP meeting. We were talking about, kind of how you can look at the security of different applications. And the thing that we like to do as security people is we want to break things. We like to take an application and we want to run it on our own system and try to hit it with all sorts of attack tools. Unfortunately, you can't do that for things like Amazon or E-Trade or your bank or your ISP, because you can't download Amazon and run it on your own server. You can only access it through the actual Amazon website. So so you can't necessarily do all the kind of attacks that you would normally do as far as trying to throw SQL injections at it or cross-site scripting attacks or whatever. So that really was the problem. So we want to say, well, how can we best figure out what the security is? So are there some things that you can look for without actually attacking the site, and then be able to make a better guesstimate anyway of the security is what it comes down to. So I got to thinking about this after the meeting, and the solution was, well, basically we want to just monitor the traffic. So let's just look at what's going back and forth between the web browser and the server and see what kind of information that's in there that we can gain. And the result was basically this presentation is going to talk about all the different little things that you can find, that there are some security relevant items that you can find just by doing passive monitoring. And the advantage here is that it's totally a passive technique, so that there's no way that the web application can say, oh, I'm being attacked by somebody, or they can come back and try to get the feds after you or whatever. And you can use this anywhere. The application doesn't even know it's happening because you're just passively monitoring the traffic. So you can use this on your bank, your ISP, whatever you want. So that's really what this presentation is going to be talking about. Just as a bit of an introduction, I'm going to talk a little bit about the Paros proxy for capturing web traffic. Is anyone familiar with Paros? Most of the people, not many of the people? I'll go over it real quick because I don't want to spend too much time on it. But the gist of it is, it's a neat open source tool, not written by me at all. So definitely props to these guys that wrote the tool. And it's basically it just runs as a proxy and intercepts traffic between your computer and the server. And one of the cool things about it is that so this is what it looks like. You'll see some screenshots later of more specific Paros things. I hope you'll be able to read them, but if not, you can look at them in the slides later. So this is what a web request looks like. I'm sure you guys know that. And so Paros is basically just kind of sits in the middle. So it's also running, both the web browser and Paros are running on your computer, and it just makes basically 2 requests. So one goes to Paros, one goes on, comes back. And what the cool thing it can do, though, is it can also man in the middle an SSL connection. So have to say, well, if SSL is running, we're going to have to do something different, because it's the way SSL works is that there's only one-way authentication. So the server authenticates itself to the client in SSL, not the other way around, unless you're using client certificates, which most public apps aren't using. So Paros just basically does two sessions, which is shown here. So you've got a invalid SSL session between the browser and Paros, but then you've got this completely valid session going to the server. So there's no way of knowing, is this Paros or is this a web browser that's connecting to me? And then what you will get on the client, you're going to get these certificate warnings popping up in your browser saying, hey, this is a bad certificate. But you don't care, because you're running this thing and you know that someone's intercepting your traffic. So that's okay. So that's a neat thing that Paros does for you. And then the other neat thing, or the other thing you should know, I guess, if you're going to start doing this, is Paros by default will actually append its own name to the user agent string on your web browser, or on the traffic that's going to the server. So if you, so occasionally applications may actually see that and say, hey, someone's running Paros against me. Maybe I don't want to let them use my application. So there's actually a flag that I don't know if it's documented anywhere, but I found it in a Google search. That there's a -no user agent you can pass to Paros, and it tells it basically don't stick your own thing on the user agent string, and then you can basically use a shortcut to do that if you want, and then we can then you'll be good to go. So basically, after you've made that change, there's no way that the application can know what's going on. So. Okay, so that takes Paros. Any questions on that? There's lots of other proxies out there. I use Paros sometimes, and I use other proxies sometimes. WebScarab by Rogan Dawes, that's supported by OWASP, is a great project as well. It's a lot more complicated out of the box. It's got some defaults that aren't quite as easy as Paros's, so it also makes nice screenshots. So, but there's other ones out there. And then I guess I'll also throw out. So I know some people came in after we started. There's a couple envelopes passing around that we've got some giveaways for stuff that I've got. So it's throw your business card or name or whatever in there if you're interested in that, if you're wondering why those are floating around. So anyway, okay, so now we've captured the traffic between our applications. So basically you're just surfing the application as you normally would, not doing anything different than you wanted to, as far as or that you otherwise would. You're going to look at, log on to your bank, check your balance, transfer some money, pay some bills, whatever you want to do. And now log off the application, and now we're just going to go back through the logs and see what we can find. So my first step is going to be just looking at the what technology is in use. Is it, what kind of software is it? What kind of server is it running on? What kind of language perhaps is the software written in? Is it written with some particular framework? Because that'll kind of help guide you in some of your later things. So the most obvious, and you don't even need Paros for this, is just looking at the URL. You can see, okay, well, this is running ASPX, so it's ASP.NET. It's legacy ASP, would be kind of a flag these days that, that means the site hasn't been updated in quite a while, probably. If you've got, JSP or PHP, then, those are pretty common. If your bank is running PHP, I'd be a little worried. Python, and then you will see Flash actually on some sites anymore. It's becoming more common. And if you don't see any extension at the end of the URL, it's probably, who knows what it is. It could be something, but it's at least they've probably got something more interesting set up. They kind of know what's going on. I do have a couple screenshots on this side, just because I want to caveat. Again, I hope you can read, but if not, you can see that this is the Yahoo Maps, and it's got index.php, which I thought was kind of weird. I'm like, wow, Yahoo Maps is running on a PHP system. But look at the source, and you see that the PHP is really just kind of a wrapper, and what's actually running is Shockwave. It's a Shockwave application, Flash. So you can't take that entirely to heart, but it's good. It's a good kind of thing to first start looking at. So then, now you're going to actually look in Paros and see, okay, let's look at some headers. Let's see what kind of server this thing is running, as far as the web server or the application server, and then look at what version it is. Because a lot of times the version is going to be right there. If you want to know whether you've got a vulnerability in the server, then that might be useful. Because you look up the version number within the vendor's page or with Google and see, hey, there's known vulnerabilities. They should be updating it. So my first example here, and I don't know if you guys can see that at all, but this is the OWASP homepage, and basically what's highlighted there is that they're running Apache 220, and it's powered by PHP 516. So that's not the most recent version of PHP as far as I know, but whether there's any remotely exploitable bugs, I don't know. But it's the kind of thing that you're going to see looking through the headers to see what the versions are being run. This is the Bank of America homepage. They're running the Sun Java 1 Server 6.1, and I really wish you guys could see those better, but I hope some of the screenshots a little later are bigger. Again, this is headers that you're going to see on eBay. Again, it's IIS, and they're running IIS 5, which is interesting because that means they're running Windows 2000, and which has been end of life. And they're also running Apache Coyote as the application server. Just interesting stuff to see. This is ASP.NET, Microsoft's homepage. And the interesting thing here that you can't probably see again is that they're running ASP. It actually has the ASP.NET version number. So it'll actually say, it says 2.0.50272. So it gives you very specific information about what's running on the system. So again, you want to go back and look and say, okay, is that the most recent version? Are there known issues with that system? Again, you're not trying to exploit the issues. It's more getting a better idea of how these people are running the system. Are they keeping things that that they should be keeping track of as far as patching things and all that. This is one, the one good one that I really found was Amazon.com. If you go to their website, it just says server:server. So that's interesting. That was definitely a good thing. Again, it's security by obscurity in some sense because it doesn't make you any more or less vulnerable, but it just makes it harder for someone to figure out what you're doing behind the scenes and what potential vulnerabilities might be there. So the other thing to look at is not just the actual server application, but also the application code that's being run. A lot of times it's going to be custom applications, but they may have some COTS components, that they may have an image gallery or some sort of forums or feedback system or something like that. So you want to look at those as well and look for the same kind of things there. You see like this particular site, it's running the Coppermine Photo Gallery 135, so there may or may not be issues with that. If you look at the BinRev forums, that you can start running Vision PowerBoard 221. So sites are nice to give you all that detail about what they're running, so that you can know what vulnerabilities might be there. Slashdot is kind of interesting in that they've got their own slash code, they call it, that is like their application code that they run. They give you the exact version number, and they've also got some other weird headers that you see. That they've got these. Quotes from Futurama, I think, is all the ones that I've seen. And you can see that this is a quote from Fry, and it says, "That's a chick show. I prefer programs in the genre of world's blanketiest blank." So there's a couple other headers you may want to look for as well, just looking at the system, especially when you start looking at the private pages, when you look at your account information, when you're going to transfer money, that kind of thing. If you've got some... So if there's private data, that the application should be kind of specifying that, hey, you shouldn't cache that data. The client shouldn't be storing that stuff on your hard drive because potentially someone will come in and grab your information off of that. So you normally see that the modern way to do it is with the cache control, no cache header. You'll also see Pragma no cache sometimes used as that's kind of the HTTP 1 version, but a lot of times applications will use both. It's probably best to use both just in case. And you could have those in headers, or they may actually be in meta tags within the HTML itself. It's basically the HTTP equiv meta tags are the equivalent of headers, is kind of how that works. So hopefully your no cache is specified on your account pages and that. It's just an example again, a slash dot. They actually, even on their public pages, it says cache control no cache, Pragma no cache. So that's a good thing. The other thing you're going to want to see specified in your headers is a content type. You're going to have a content type that says text HTML, but then you're also going to want to see the character set specified. So the character set specification is what tells it, is this, just kind of standard ASCII, which is generally ISO 8859-1 character set, or is it Unicode, 8-bit Unicode, or 8-bit Unicode, 16-bit Unicode, whatever, UTF-7, UTF-8. So that's useful because the reason you want to specify that is if you don't specify a character set, the browser has to guess. And a lot of times it'll guess wrong if you force it to, because there's certain types of cross-site scripting that exploit UTF-7 vulnerabilities in the sense, because UTF-7 allows you to create and less than signs without actually using greater than less than. It uses like a plus and then a hex code and a minus afterwards. So if you're not specifying a particular character set, then the browser may be able to the application, an attacker may be able to force the browser to think that it's UTF-7 encoded, and the browser will interpret it that way. Most browsers are kind of set to automatically detect by default. So if it'll just try to make its best guess, and if it sees what looks like UTF-7, it'll say, oh, this must be UTF-7. me interpret it that way. So that's something else you should want to see. There's again Bank of America. You see they're specifying the content type, and Google actually shows it twice. It's got it up in here, up in the content type header, and then it also shows it again in a meta equiv tag. So that's a good thing you want to look for. So if you don't see that, that's an indication again that the site may not have all of its kind of security things put together. You know, a lot of the things we're going to talk about may sound like issues individually, but you can kind of put them all together and give you a better idea of the application. If they're missing all of these things, then that maybe is a bad sign. If they're missing one or two, maybe not so bad. And it also comes down to you got to make do with what you can do. I mean, there's only so much you can do through passive looking, so it allows us to make our best guess is really what it comes down to. Okay, so any questions on headers or anything else up to this point? Like I said, feel free to ask questions if you got them, or throw a Shmoo if you want. Okay, so let's move on. So one of the things that I noticed in looking at some sites is that a lot of sites are using tracking beacons. They're using some sort of third party to track, you know, their visitors and see who they are and you know when they're coming back and whatnot. So when you look at Paros, you'll see kind of a list of all the requests, and a lot of times you'll see requests to these type of people, Google Analytics, Clickalizer, or whatever, and you want to be careful about those. One of the things I've also noticed is a lot of them now are sending JavaScript. They're not just sending an image. It's not just kind of like a 1 pixel image or something like that that's being pulled in from those sites. They're actually pulling in JavaScript and other types of active content. And so you got to be a little bit worried about that, because if your bank is using, you know, Billy Bob's click tracking site, then they're not going to be able to protect themselves against that site. So if someone breaks into the data aggregation site, they're going to be able to know, hey, you know, now I can run cross-site scripting attacks on everybody that uses this. So that's definitely something you want to look out for, as far as if they're pulling in JavaScript or other active content from you know, questionable security sites, you got to be wary about that. So does that make sense? I think I assume you guys are familiar with cross-site scripting and kind of what that's all about, and that's the essential gist of what you get, because they're just pulling the script directly from there. So one of the things we want to look at is how you log into the application, and just a quick primer. Like I said, I tried to structure to be pretty general. So if you've got when you're doing a login to an application, you've got basically how do I want to say it? HTTP authentication. So standard HTTP authentication is when you get this pop-up box that comes up in your browser. It says put in your username and password. You're not going to see that normally on internet sites. You may see that on intranet sites, so I just wanted to mention it. And normally what you're going to see, though, is your standard forms-based authentication. We'll talk a little bit more detail later. But if you see basic authentication, that's bad. And that's because basic authentication is essentially plain text. So this is actually just kind of a generic test site for OWASP created called WebGoat, and they use basic authentication. You can see the header there. It's basically base64 encoding the traffic and then sticking it on every request. So it's not encrypted at all. That's definitely not a good thing. If you see digest authentication or NTLM authentication in use, that's a good. But most of the time, you're going to see form-based login. So it's going to be a form that gets submitted that then has some data in it that you stick up, that gets sent back to the server. So you're going to look at the form and look at a few details. I mean, is the form itself hosted on an SSL page? Now, granted, the data gets submitted something else that we're going to look at later. But if the form itself is not hosted on SSL, there is potential that someone could have messed with the form in transit. Especially if you look at, you know, you're logging in from, you know, a coffee shop or something like that. Someone could be sniffing the wireless network, could have kind of sent you back a bad response that, you know, your URL says this is bankofamerica.com, but the content is actually getting submitted somewhere else because it's been modified en route. So by hosting the form on SSL, it prevents people from screwing with it in transit. And then you also want to see, is it submitted using a post request? Because not every website does that, surprisingly, which is a problem, because GET requests are sometimes cached in proxies, and they're kept in your history a little bit differently in that. So if it's submitting your login over a GET, that's not a good thing. And I'll show an example of that in a little bit. And then also, is the form itself submitted to an SSL site? So in addition to being hosted on SSL, is it submitted via SSL? Because, you know, you can mix and match. You can have a form hosted on a HTTP site that submits to HTTPS, or vice versa, or, you know, both the same or different or whatever. So you want to look at that. And then you also want to look is the password sent as it is, basically as you typed it, or is something the client browser, which very few sites actually do, but it's a good thing if they do. So, looking at login forms again, this is the login form for MSN, or it's actually MSDN. I was trying to log into, or a Hotmail actually. Hotmail, yes, it's Hotmail in this one. And you can see that it's actually posting data, and it's posting to an HTTPS site, which again I know you can't read, but you can see up here, we don't have the little lock or anything. It's not an HTTPS site that the form is actually hosted on. But there's a nice little link that that right here that says it says sign in using enhanced security. So if you click on that, you actually get to a nice site with a little lock and yellow URL bar, but it's actually posting the data to the exact same place. So it's helping you in the sense of that the form hasn't been messed with in transit, but it doesn't. But it's still submitting data to a secure site, so that's good. So we give them a check mark for that. You look at E-Trade, for example, you see that their form is their homepage is basically on SSL. And I'm glad to see that a lot more banks are doing that these days. It used to be that a lot of banks and stuff, they didn't want to have SSL on their homepage because they got so much traffic to their homepage that it would cause them just took more cycles for them to keep running SSL on that. But then they also wanted to have their login form on the homepage because they wanted to make it easy for the users. So that was a problem more a few years ago. I think nowadays most of the sites are having SSL right on their homepage. If you go to the regular homepage, it just redirects you automatically to the HTTPS site. So that's what E-Trade does. I just typed in E-Trade and it redirected me to the HTTPS site. And then it also the target is actually just a local target, so it's not a full URL. It's just a relative link, which is good because then it's still on SSL. And then again, you can also see here, if you can read it, it says method equals post. So that's what you're going to be looking for. If it says method equals get, then that's a bad thing. Okay, so when you submit a password from your web browser, the web browser really doesn't treat it any differently than any other input. It treats it a little bit differently within the user interface because it shows the little dots instead of the actual password, and it shows it gives you the ability to remember your password. It'll have the password login remember thing. But basically, it's submitted just like anything else, and there's nothing special. So most applications will just take that. So they just take the application, from the application's point of view, the password's coming in just as it is. In reality, most of the time it's coming over HTTPS, so that's giving it a layer of encryption at that level. But sometimes you do see applications that are running without HTTPS. So in that case, you definitely want to look for an application that's hashing data within the client, so it's not just sending it in plain text. So if you look at this is a Yahoo login, you can see it's just sends the password. So that's sending it normally. Slashdot runs entirely over HTTP, but it's not really an e-commerce site. So, but again, it's just sending the password. Interesting thing when I was looking at MSN. Or I think this was MSDN when I was logging into there. It sends the password in plain text. I changed it from my password here just so you guys wouldn't pwn me. But it also has this little pad that I'm not sure what it's used for because it didn't actually end up anywhere else. But it says if you're reading this, you have two. And then I went back into the application code and I found in JavaScript it actually says if you are reading this, you have too much free time. So I thought that was an interesting thing that I found there. But what you should be looking for in login, especially if its site is not hosted over HTTPS, is that they should be hashing the password. So the password shouldn't be sent just kind of in the clear. It should be hashed a couple times actually before it gets sent, because ideally, in my world anyway, the server shouldn't actually store the password at all. The server should only keep the password hashed with some kind of random server string, because that way even if someone breaks into the application, they can get the hashes, but they can't learn your password to go log into other sites that maybe you use the same password for. But so the application would have that, and then when you want to actually log into the application, it's going to send you the server string and then also a random string, and the client kind of hashes that a couple times and sends that back to the server, and the server can recalculate that. I have never seen an application really doing all this. Yahoo does, and I'm going to show it in the next slide, that they have kind of a halfway version of this, that they hash the password along with a challenge, the session string, but they don't have a server string. And so sometimes people, application developers don't necessarily like this scheme because they kind of like to have access to the password sometimes, because they may need try to synchronize accounts between different systems, or they may want to try to, if you want to recover your password, they may want to send you the original password, which normally they shouldn't do, but doesn't mean they don't want to. So if you look at Java, or at Yahoo's login, they've got some JavaScript code here that actually it implements the MD5 algorithm. They actually took it from another guy, Greg Holt. So props to him. And you'll see that in their code, they'll actually take the value that's put in for the password, they hash it along with the challenge, and they send that back. So when I logged in one time with a particular username, you can see that there's a password hash there, and I logged in the next time, the password hash is different. So that's a good thing. That's the kind of things that you should be looking for as well. And I'm going to take one quick break here to get a drink of water. Any questions while I'm taking a break? Good. Okay, good. Well, another thing that you should see during your login process is you should see a redirection. So your application shouldn't be storing the result of a post on the or of the post of the login form directly, because that means it's going to appear in the history. That means that you potentially could go back and hit refresh and then be able to relog into the application if you walk away from your computer. I guess an attacker could do that. So, and actually, I was surprised to know that Amazon.com. I don't want to put their name on the slides here, but they actually are vulnerable to this. That they don't send you a redirect on login, so you could go back and repost data. So what you should be looking for is some sort of redirection in response to the post. So in these slides here, I've got a post here that shows, now I'm actually sending data to the application to log in, and this is the response. So the most simple thing that you'll see a lot of times is a 302 HTTP message, which says basically redirect you to somewhere else. So that's a good thing if you see a response. Another thing that you may see is, again, a meta tag. So you may see a meta refresh tag that says, we're going to go ahead and refresh, send you to something else. So it basically says refresh and in 0 seconds. So basically immediately refreshes it and sends you somewhere else. So that's a good thing. Or you can see JavaScript. MSDN, I think, is where I saw this. Or no, it's Expedia, I guess. They had a JavaScript function that actually redirected you. It basically replaced the URL and with another site. So that's fine as long as you know JavaScript is enabled on the client, because obviously if it's not, then you've got a problem. In this case, it's a little strange. They've got some of this no script stuff at the bottom, but the application itself, like when you go to try to log in, if you have JavaScript disabled, it's going to kind of kick you out and tell you that you can't do it, which is annoying. But sometimes you got to make compromises. So any questions on that? Sure, go ahead.
Locked away that you can't, that's obfuscated, that maybe you could get the file names for that kind of thing out of the browser?
Yeah, the question was, it would be useful is trying to find maybe perhaps some media that's being locked away behind some DRM type protections and that. And certainly it can be useful, because one of the things you can do with this is you can actually know the raw requests that are being made, and see them and know exactly where stuff is. So maybe you've got some sort of funky Flash application that's trying to prevent you from like downloading images or something like that, and you can see where the raw requests are going and go grab them. The other thing, by default, Paros actually doesn't capture any of the image requests, but there's a checkbox in the options you can turn off for that. So does that answer the question? Cool. Okay, so I want to talk a little bit about session management, because you guys probably know HTTP is not stateful. It's basically a stateless protocol. You have to add some other stuff on top of HTTP in order to kind of track who users are. And there's kind of 3 ways of doing it. The most common, obviously, is cookies, but you will see people using URL parameters and occasionally hidden form fields, although that's kind of a pain to implement if you're not using a framework that does it for you, because it basically means everything on your site has to be a form submission. So you can't have like regular links anymore. So when you look at a website, you want to look at what sort of session identifiers are they using. And in particular, are they using some sort of standard thing like the ASP.NET session ID or JSession ID, or have they kind of made up their own stuff? Because generally, if they make it up their own, it's probably not very good, or at least it's not as good as the standard ones that can be used out of the box, unless they're a pretty good site. So in a non-standard session ID, you're basically going to be looking at, is it random and is it long? Because if it's not random, if it's just session IDs, then obviously you could just go in there and change, you know, the session ID, increment it or decrement it to start accessing other people's accounts. And hopefully not many applications are vulnerable to that anymore, but I know it definitely in the past there were a lot of them that could do that. And are they long is just a matter of, you know, can you brute force it? Can you just start guessing session IDs at random and hope to find one? So that's what you want to look for. And also, you may want to look at how long is the session valid. You may just want to, you know, kind of walk away from your browser for when you go out to lunch or at night and try continuing the session later. Because if they're not expiring sessions after so much time of inactivity or even so much time of activity, then that's an indicator that they probably haven't kind of looked at the whole session of the application and security of it, I guess. But like anything else, you know, those kind of issues kind of come down a bit to a judgment call in their case as far as, you know, how secure do they want to build the application versus how easy do they want to make it for their users. And especially e-commerce websites, you know, they definitely have incentive that they want to make it easy for the users because they need customers. So some of those you have to take with a grain of salt, but it's definitely things to look at when you're looking at the whole thing. This is just an example of a JSession ID from the sun.com page, surprisingly. And this is an example of ASP.NET session ID from Windows. Plays for sure. So those are good cookies. I didn't have any great examples of bad session IDs, but there's definitely. I tried to keep the number of bad examples kind of sanitized here so that we can I wouldn't get myself in jail, I guess. One of the other things to look at when you're looking at cookies is cookies can hold all sorts of data. So if they're storing other stuff that looks weird, then you may want to kind of take a closer look at that. If you see prices, account numbers, any sort of kind of personally identifiable information, that's potential for problems. I mean, the application really has no reason to be sending that stuff to the client because from your session, you'll be able to pull all that stuff from the session object on the server side. And you also may want to look at the cookies as far as how long are they valid. I mean, if the cookie's valid forever, then that at least may be an indication that they're trying to track you and that, which is not necessarily a good thing. And if there's no expiration date on the cookie, then that's a session cookie. So it just basically will live as long as the browser is open. There's a couple other flags that you may see on your cookies that are good, you know, although they're not, you know, the end-all be-all of things. But you know, the secure cookie basically says that this cookie can only be sent via HTTPS. So it's not going to be available through the regular HTTP protocol. So if maybe you accidentally type in just a standard HTTP link, or there's a link on the image or on the site to an image that's on an HTTP site, it's not going to send your cookies, because again, if your cookies are sent over plain text, then potentially someone that's sniffing your traffic at the coffee shop could then be able to log into the site as you. So you want to see that secure flag, and then you want to HTTP-only flag, although it's really only supported in IE right now. Firefox 3 is supposed to be adding support for the secure cookie flag. Or no, I'm sorry, Firefox has support for secure cookies. Firefox 3 is supposed to be adding support for HTTP-only cookies, and I think there's an extension you can download to give it in the earlier versions of Firefox. But this is just an example of the secure cookie flag. It just says secure on the site, and the HTTP flag, it just says HTTP only is all you're going to see there. Again, I know you guys can't read some of this stuff, so I'm just running through it to give you examples. Yeah. Secure you'll see a lot. It's not all the time because it depends on the site. I mean, a bank or something like that is usually doing it. The question, I guess I should repeat, is do you see that a lot, the secure cookie and the HTTP only cookies? And so the banks, I think you see that a lot. Things like Yahoo and that, they don't, because they don't run their entire site over HTTP. They only do login over HTTP, or I'm sorry, they can't run their entire site over HTTPS. They just do login over HTTPS, and then they dump you back to an HTTP session for performance reasons. So that's not as good. Even Amazon and stuff, I think they're running the majority of their site over HTTP. So yeah, the secure cookie flag really isn't going to work. That makes sense? And HTTP only, I guess I should address, it's pretty rare that I actually see sites that are running that, and partially because it's only supported under IE, and sometimes there's reasons, because basically what the HTTP only means is that JavaScript can't access your cookie, which is kind of cool because it prevents you from some sorts of cross-site scripting kind of attacks. But sometimes they actually want JavaScript to be able to access the cookies because they're doing weird stuff in JavaScript, especially nowadays with everybody running AJAX applications. So you're not seeing that as much. And again, until all the browsers support it, it's not necessarily a big push for it. Okay, this is just interesting cookies I saw. This was the Starbucks website. They actually have a cookie which I can't even read on my screen, but it's basically, it has the URL within the cookie. So it has kind of a yes. Is there a question? Yes.
Can you comment on the prevalency of sites locking session credentials to IP addresses? I mean, we know there's a problem behind that with the same thing. Have you seen people doing that? And if you have, can you suggest a way to check for it?
That's a very good question, because actually the next slide here I have is an example of what I think is that, although I didn't actually try it. The CVS website, you can see one of their cookies, it says shopper ID, and the first part of it is actually my IP address. So I sanitized it here, but it was my original IP address. And I guess it was maybe they were just doing that until I logged in and they had like some sort of idea of. So I've seen that on other sites as well, that they're putting the IP address in the cookie in order to try to track you, I think, in that sense, and it helps prevent some sorts of session fixation types attacks. So but I haven't actually tested it to go like, okay, now I mean, you could do it, and again, the whole idea of this presentation is that we're not doing anything that's going to be like attacking the web application. But you know, if you start your session with one IP address and then you close up your laptop, don't close the session, go to work and start doing it from a different IP, see what happens, is kind of what you could do, is just in the simplest sense. But I haven't seen a lot of strict tying to IP addresses. There's some issues with tying sessions to IP addresses that people will run into. So not sure how many applications are actually doing it. The main issue, I guess I should mention, is that AOL has their web accelerator proxies that they use, that people that are using that will actually be coming from a kind of a set of IP addresses. They actually bounce between those proxies in some sense. So you can have legitimate sessions that are changing IP address. I think it's becoming fewer and fewer these days with more people moving to broadband, but it's still out there that you'll have problems like that. So those are a couple interesting cookies. I also saw the CVS site. They have a referring site there that's listed. So I'm not quite sure what that is for. I guess I should also mention the reason I thought this Starbucks site was kind of interesting is that, like I said, it has a cookie there which, and it seemed like every time you clicked a link, it was sending you to a different URL. So I wonder if there may be a redirection type attack there. If you could force a cookie to be set somewhere else, then you could redirect their users to something else. But again, I'm just kind of looking at them. You can kind of only speculate at this point. There's not a whole lot you can do to figure out exactly what's going on. So one of the other things you want to look at when you're looking at sessions is the application vulnerable to session fixation? So I got to explain a little bit what that means, I guess, in order to know how you prevent it. And the basic idea of session fixation is that if a session ID is issued before login and then it's continued to be used after login, so the same session ID is used for your entire session from before you log in until after, then you've got the problem that if an attacker can force somebody to use a particular session ID, then they can basically send you some social engineering or whatever and say, hey, log into your application, here's a link. They click on the link, it sets the given session ID. Once you've logged in, now can have access to your account because he knows what the session ID was. So what you want to see is that responses to a login, a successful login anyway, should give you a new session ID. So either the application shouldn't give you a session ID at all until you've logged in, or they should wait until afterwards and then basically reissue you a new one. So I don't have any great examples of what that should look like, but one of the things that really you'll see a lot, and this is, I couldn't help but put Network Solutions in here for their SSL certificates, that session fixation is much easier to do if you can put the session ID on the URL. So a lot of applications will actually default to putting your session ID on the URL line if cookies aren't enabled. So one of the things you can do as you're kind of playing around with your bank or whatever is turn off cookies and try to log into the application and see what happens. Turn off JavaScript and try to log in and see what happens. Because definitely the application is going to behave differently. And this is usually, this is a JSP application. I don't remember what server it's running, but things like WebLogic, WebSphere, whatever, they've got kind of built-in session tracking mechanisms. So the application doesn't actually even take care of this. The application server knows, hey, I'm going to try to set this session ID in a cookie, and if it doesn't work, then I'm going to do something else. The application, the people that actually wrote the application don't even realize some of this stuff is going on. So if you see a session ID in the URL bar, then that's an indicator that it's a bit more vulnerable to session fixation just because it's really easy to put it in a link. You can other ways, sometimes through posts and other stuff, but it requires a bit more wonking around. Okay, any questions there? We're doing okay on time, I think. I'm going to try not to take too much of your time, but if there's any questions, feel free to throw something up. So one of the things you want to look at is forms. It's just kind of a good programming practice. Forms should be submitting data via a post. So if you're submitting data over a post, that means that it should basically having some kind of size or effects within the application. Now, granted, if you're just searching a website, that's fine to be through a GET request. But if you're making anything change in the internals, then it should be a POST request. So, one of the reasons for that is that you'll get this nice confirmation box if you try to repost data, because it'll basically, if you transferred money, for example, it'll be like, well, I don't want to transfer more money without asking you. So that's definitely a good thing. But unfortunately, not all web applications actually follow that, and there's ways you can do it with other things. But this is the eBay. Actually, I was looking at their site and made a bid on an item, and you can see that actually it makes a GET request with your bid, which is not the greatest way. It definitely makes it it makes it easier for cross-site request forgeries. It also, surprising, is it's not over HTTPS. It's just sending it over regular HTTP. So that's not the best programming practice. Whether it's a vulnerability or not, you'd really have to kind of test around to see, what kind of parameter tampering you could do to make things happen. But the other thing you want to look at on forms is look at what your hidden form fields have. If forms can have fields that are called hidden, but they're really not hidden in the sense of the browser can see it. If there's some Firefox extensions that'll actually show you hidden form fields, which is kind of cool. But definitely Paros can see it. They're going to see the data coming back and forth. So if you see hidden form fields that have things like prices or discount information, like 5% discount or something, account numbers, anything like that, that's an indication that they're doing something weird that they probably shouldn't be as far as trusting data that's coming from the client, especially because really there's no reason to send this stuff to the client in the first place if they're just going to receive it unaltered. Now, account numbers, maybe there's a legitimate reason because you're logged into your bank and you've got 3 accounts and you've got to select one account number to transfer to the other. Well, that kind of makes sense. But if you've just got one account, then there's really no reason for that to be there. And then prices, obviously, there's issues there, and I'll show an example of that in a second. And just also the .useState hidden form field sometimes is used for session tracking sessions. Sure. The question was, is there any attacks or abuses of the view state as far as just being able to track, have the person really log through there? Well, I know that there's a few options to the view state. There's a way that you can kind of, I think it's like a hash or some sort of encryption or something that's supposed to, so that someone can't just replay attacks. But I think by default it normally doesn't do that. It's changing as you're browsing the application, but it's not kind of specific per user from what I understand. So there's ways that you can resend some of that data. And in reality, it just makes it a little bit more complicated for the attacker, because the attacker can just decide, okay, well, I don't want to, one of the things the view state will do is it'll prevent you from just sitting there reposting a form with a whole bunch of different parameters trying to do attacks. But your scanning engine could just decide, okay, I'm going to make it like a 3-phase attack. So I'm just going to log in and then go to this form and then submit it. So it's not, I wouldn't rely on it too much for security. It's more for just kind of how they do things as far as managing the session. Okay, so this is an example of a site I obfuscated just so you guys wouldn't all go try to buy stuff from them. But you'll see that actually it's a post. What this is it's actually a third-party shopping cart that's this service. So they're basically, the original site just posts data to the other site, to the shopping cart, and it just includes right in there, this is how many we want and this is the price. So it's very easy that if you were malicious, you could just intercept this, because Paros, one of the things that I didn't talk about with Paros is you can intercept requests. So you can grab a request as it's going and then change the data. So you could change this price to 0 or a negative number or something like that and see what happens. So definitely, if you're seeing prices flying across the wire, that's not a good thing. Another thing you want to look out for that I don't have time to completely cover, but cross-site request forgeries. Let me see what time it is, actually. What are we at? Oh, okay. We don't have a whole lot of time, so I'm going to fly through some slides here at the end, and then we can feel free to ask questions later. Cross-site request forgery is basically where you're looking at getting data from one site that's being sent to another. So HTTP allows a site to make a request or force a request, the client browser to make a request to another site, you know, that's just part of the protocol. And gets are real easy. You know, all you have to do is kind of an image source. So if you look at a lot of web applications actually have this on their sign out page. So you could Yahoo, you know, the sign out isn't some sort of form submission. It's just a standard, you know, link. So you put an image source this into your own website and you've logging people out of Yahoo. Same with Expedia. It's just a regular link. Same with Slashdot. Posts can also be vulnerable to CSRF, and so but it's not. It requires a little bit of JavaScript or some social engineering to get them to actually click the submit button. Because again, you can post any site can post a form to any other site. There's no restrictions within the DOM or anything that prevents that. So what you should see on your forms is some kind of random looking values called a nonce that'll actually in a hidden form field typically, that'll just kind of remember what's going on with your application so that it'll know that, hey, this is a form that we gave to this user, that user must be trying to submit it. It wasn't some other guy forcing that request to our application. Because really the gist of CSRF is that in addition to any site being allowed to force a request to another site, your browser is very nice in that that force request is going to send all your cookies and other stuff along with it. So that's really the gist of why CSRF is a problem. And some people will check referrer headers to try to prevent CSRF. That's not always reliable. Not all browsers actually send referrer headers, so that's not always a perfect either. You're also going to look for what data is actually being submitted to your forms, and definitely you want to look for SQL queries or anything like that, or again any of your account data, kind of the same stuff we talked about with cookies. Because if they're sending that kind of data, then it's an indicator perhaps that they've got not the best practices, and definitely could be a security issue. Because I found this site just today with a simple Google search that you can read off the page if you're clever. But the gist of it is that it just says select star from the categories where category ID equals 13, and it's even got some like single ticks and stuff in there. So it's got the entire SQL query within the URL parameter. So that's definitely a bad thing. If your bank's doing that, then I would find another bank. A couple other quick items. A lot of people are going to AJAX applications these days, and sometimes it's not always real obvious. I mean, you go to Google Maps, you know, oh yeah, that's obviously it's AJAX, but a lot of even you know banks and that sort of thing are using AJAX type recalls for certain parts of it. So if you're curious to know if that's being done, look for uses of XMLHTTPRequest. That's a useful thing, and also just look for queries that or requests that don't send back kind of standard HTML. They send back something else. So, and also the good thing about AJAX is that they expose a lot of their internals in the client code. So your JavaScript that you've downloaded and you've got captured in your Paros has got a lot of the internals of the application. So you can kind of reverse engineer that. You don't even have to decompile it. It's all source code, really. It's script. So that can be fun to look through and look for security issues. And this is just an example. That's the HTML request. And this is just kind of a JSON type request that's coming back from Google Maps, where it's basically you're making a standard HTTP request, but you're getting back what's just kind of a bunch of data. There's no HTML tags or anything around it. You also may want to look for some HTML comments. Those can be fun. This is a comment on this is on BinRev's homepage, and it's basically it says stankdog : is used by Alexa to display traffic. I'm also testing some other interesting functionality with it. So that may be an indicator that there's something interesting that you may want to look into there. And again, this is the kind of issue I talked about earlier where the BinRev page is actually pulling JavaScript from this other site from Alexa. Alexa is a web tracking system through, I think it's run by Amazon. So that's it. On that, and logout, we also want to talk a little bit about is, you know, one, is there a logout system available? Applications that there is not a logout, and also does it actually log you out? You know, it should be setting a cookie, you know, that's basically deleting the authorization cookies that you've already got. And you may want to, you know, just try to see. Sometimes it doesn't actually work. You can just go back in your browser, hit refresh, and stuff works. I also noticed on Expedia, it's got a nice little logout button that you click, which we talked about before. But you also see that after I've logged out, it still knows who I am. It still says, "Welcome, Charles." So apparently, its sign out doesn't really mean. So that's a little annoying. A couple other quick things. Flash is one of those things that you'll see more nowadays. People like the fact that you can do cross-domain stuff and with Flash, which is a bad thing for security reasons. It breaks DOM and allows CSRF. There's no way you can protect against CSRF if you've got this kind of Flash cross-domain stuff set up. So if you see your site is allowing access with a cross-domain.xml file from everywhere, that's a bad thing. example of Yahoo's Maps application where they're actually doing the right thing. So they've got it restricted to, they've got a cross-domain.xml, but it's only restricted to a few domains. This is another application. This is actually another web tracking system that they've got a cross-domain policy that's basically says allow from everywhere. Again, this is not a huge deal because it, again, you can't read it, but the site, this is not the original site that has the cross-domain. So it's not my bank that has the cross-domain allowing everybody to connect. It's the web tracking system, which they may need to for whatever they're trying to do within their broken system. And obviously, if you've got applets, which, you know, applets do still exist, you know, pull them apart. You know, there's decompilers out there for Java applets, and there may be fun stuff in there. So anything else fun to look for? Anyone else got any ideas of something I didn't mention? Sure, go ahead.
The web trends and traffic analysis, you could look to make sure that your session credentials are passed along with that information.
That's a good point. When you see those requests for other sites, you may want to look at, such as web tracking, you may want to see what other data is being sent to those sites. You know, is it sending your credentials or session ID or something like that? Obviously, that's a problem. And how is it sending it? Is it sending it over clear text or HTTPS? Good. Any other? Sure, go ahead.
If you look at some of your standard enterprise collaboration applications like SharePoint and BEA, those kinds of things, and see there.
The question was, have I looked at SharePoint and BEA and those kind of collaboration applications? I really haven't. I was really looking at internet sites for this, but you could certainly run this on any of them and see what's there. SharePoint's got its own issues as far as they want to kind of let everybody do everything, which is a problem. You run into lots of cross-site scripting kind of issues with SharePoint from what I've seen. Other questions? I've got a few more slides that I'll just throw out real quick. Is that, you know, things you may want to look at that aren't entirely passive, so at your own risk, you know, look at the forgot password feature, forgotten username feature. You may also want to try some other interesting things where appropriate. That, you know, if it's got a search box, you may want to search for, maybe the site has something about Conan O'Brien or some other person with a single tick in their name, and, you know, look for some. Also, maybe you want to send some HTML tags, but in general, you be real careful when you start going down this road because, you know, there's a line somewhere that no one knows where it is of what you can do on a public site and what you can't. So I think that finishes everything up. Any other questions? Sure, go ahead.
Because my bank, if you forget all of your credentials and you call them for a reset, they'll reset it to the last 4 of your social.
Yeah, that was a good point. Is along with kind of the forgot password feature, is the gentleman mentioned that some banks and other places, they'll have default credentials that they're going to set your account to when you first account or when you first if you forget your password and completely forget everything and have to call them up. So definitely be interested in that from when you very first start with an application. Good. Any other questions or comments? Cool. Well, thank you much. I appreciate it. Oh yeah, I gotta draw someone's name here for our training thing. So let me see. Oh, okay. Well, hurry up. Okay. If you didn't get the thing, feel free to come up and throw it in here real quick. Go ahead. Okay. Okay. Hopefully the person. I do have a couple questions. Okay. Thank you very much. Give me 1 second for this. Cool. Thanks. What about a training class? Yeah, I'm going to be putting them up. I think we're going to. If not, I'll put them up on my website. Afraid I don't. You can, if you're very quick, because I got to. Daniel Turner? Is he still here?